Here we have problem 13 from our final exam review, and we're wanting to see if there's a relationship between two categorical variables. So our two categorical variables here are the type of crash, either single vehicle or multi-vehicle, and the type of vehicle, car, pickup, or SUV. Is there some sort of relationship between the two? In other words, is one independent of the other? Well, we assume that they are independent. You can't assume that everything is dependent on something else. You assume independence. So how do we test for independence? Is we do a hypothesis test. For a hypothesis test, first thing you do is you set up your null and alternative hypothesis. The null hypothesis, we assume independence. The two variables are independent, and then the alternative is that they are dependent. All right, so the null hypothesis, we assume that they are independent, and then we have to prove that they're dependent with the alternative. So let's read the claim. It says, let's see. You work for an insurance company studying the relationship between types of crash and vehicles involved. You take a sample. Can you conclude that the type of crash depends on the type of vehicle? That's an alternative claim. That's the alternative hypothesis. The alternative hypothesis says that they're dependent. That's what the claim is that they're dependent. So that's the alternative hypothesis. All right. So next they ask us for the degrees of freedom. So here the degrees of freedom is the number of columns minus 1 times the number of rows minus 1. So let's see, how many columns do we have? We got 3 columns. Look, 1, 2, 3. 3 minus 1. And 2 rows, single vehicle and multiple vehicles. 2 minus 1. So that is 3 minus 1 is 2. 2 minus 1 is 1. 2 degrees of freedom. Two degrees of freedom there. Number of columns minus 1 times the number of rows minus 1. Okay, next. They want me to find a critical chi-square value. That's from our chi-square table. So I need to look up a chi-square table. Right, here it is. So what I say, 2 degrees of freedom, and our alpha value, I forget what the alpha value was. Our alpha value is 0.01. All right, 2 degrees of freedom, 0.01. All right, so our critical value is going to be 9.210. 9.210. For a chi-square, we always just have one tail. So that's our critical value right there. 9.210. Okay. .210. Not 90210. That's a 90s show. 9.210. All right, so that's good. Now what? Where do we reject? We reject on the tail, so anything that's greater than my critical value. Strictly greater than. And now it says, well, let's take our sample and see if we can make some sort of conclusion. Upload your sample. There's my sample. And remember the test we got to do here is the chi-square test. So the chi-square test is under Stat, Tables. This is called a contingency table. So it's stat, tables, contingency. And here we have a summary of the data. And then it says, well, where were your rows at? Our rows were the, what, type of vehicle, right? Or I guess they called it type of crash, sorry, type of crash. And then what were your columns? Well, your columns were car, pickup, SUV. Select them all. And there's the chi-square value. There it is. All right, so 3 decimal places. It's good. All right, so let's see where that is on our graph. Our chi-square was, what, 2.913. That is right, about right there. That is not in the reject zone. That is in the fail to reject zone. Fail to reject the null hypothesis. All right, so fail to reject the null hypothesis. That means there's not enough evidence to support the claim. Why? Because the claim was not the alternative hypothesis. The claim was the claim was the alternative hypothesis, not the null hypothesis. We did not reject the null. I'm not going to reject you. I'm going to check mark you. That means that the claim is not supported. If this gets the check mark, this gets the X. All right, so what did we say? It does not support the claim. What was the claim? The claim was that they are dependent or that they are related. It does not support the claim that they're related. All right, number 14. Number 14, let's see what it says. It says that a pie chart shows the distribution of opinions of parents on whether or not college education is worth it. An economist claims that the distribution of teenagers is different than that of their parents. All right, so this looks like one of those goodness of fit ones, right? Where you think that we got 2 different models. One model is from what we expect to happen, right? We expect the parents and the teenagers to be the same. That's the null hypothesis. The null hypothesis says that the expected, maybe I can do better, the expected, this is number 14, the expected and the observed are the same. And then the alternative says, no, they're not. They're different. The expected and the observed are different. All right. So let's see what we got. The null hypothesis says that they are the same. And the alternative says that they are different. So what's the claim? You got to read in this question here. Let's see. An economist claims that the distribution is different. Well, who said it's different? The alternative hypothesis, right? The alternative hypothesis says that it's different. And then it says, well, take that sample and give me a chi-square. Well, okay, we can do that. I can upload that data, and that data is what we observed. I'm going to put a O there, or maybe a OB for observed. But what did we expect to happen? We expected this pie chart, right? We expected 51% to be strongly agreed and 32%. But we're not going to use the percents. We got to convert the percents to frequencies. So we got to think, how many people did they ask? They asked 201 teenagers. So we apply these percents to 201 individuals, okay? So we're just kind of thinking like, what if there was 201 parents? So we got to convert all of these to frequencies. So I will look in StatCrunch, and I will tell StatCrunch, I did not mean to do that, tell StatCrunch to go ahead and in data, go ahead and let's compute a new expression. In my new expression, what I want to do is I want to take that expression, and maybe not quite yet. Let's go ahead and put in those percents. I'm going to put in the percents as decimals. So 51%, 32%, 6%, 7%, 4%. And then I'm going to tell StatCrunch from there, let's take our data and let's make some new data. Let's compute an expression. And that expression, what I'm going to do is I'm going to build an expression that takes all of my observations and multiply it times all of the values in variable 3. That was all those decimals. And let's see, will that do the trick? I think that it will. Let's compute that. And there it is. That looks pretty good. All right, so you can do that in a calculator. You can take 51% of 84, 32% of 6, or sorry. No, I did that wrong. Sorry. Let's go back and edit it. I want to take all those percents times what? Times 201 times the total. All those percents times the total. Sorry about that. Let's take a look and see what that is. I'm just going to go ahead and erase that. Okay. Now we got our observed. Now we got our expected. That is our expected. We took our total times the percent, right? 201 times 51%, 201 times 32%, so on and so forth. Okay, now we can go ahead and get our chi-square value. That's under stat, goodness of fit, chi-square test. Our observed, I already labeled observed. Our expected, under expected, I did that labeling. We can compute that and get a chi-square that's a very, very high chi-square value. I'll copy and paste that in. To 3 decimal places. I'm a little bit scared about that because that seems really high, but let's see. Okay, it just is what it is. And then it says, well, what's the p-value from that? P-value's on that same readout. That says it's less than 0.0001. So that's essentially 0, right? Rounded to how many decimal places? I'm not sure what they want. Rounded to 3 decimal places. Okay, so that is 0. It's like no chance at all. So what do we say? We say if the p-value is less than alpha, reject the null hypothesis. And then what was the claim? The claim was that they are different. Okay, so if the null hypothesis is rejected, then the claim is supported. There is enough evidence that they are different. All right, this video is almost 15 minutes long already. So maybe one more video for number 15. Talk to you soon.